We've seen in action the VLookup, where you must have an exact lookup value. So you're taking a person's name or a month, looking up in the lookup table, and you're having to find an exact match. Not the nearest, not the closest, but it has to match exactly letter for letter, number for number. Now there are times when that isn't really very realistic. In our examples here, on the nearest match file, you'll find we have some dancers and their scores for 3 different exams. Now if we wanted to do a VLookup for their score, to say, okay, 45%, what grade does that get you? We would have to create a lookup table that had a grade for every single possible percentage. Now luckily, there aren't part percentages, but that would still require a table with 100 rows in. Whereas our little table, if we look at the grades sheet, actually only contains 4 rows. 0 to 55, well effectively 54 is a fail. As soon as you hit 55, that's a pass. As soon as you hit 85, that's a merit. As soon as you hit 90, that's a distinction. So anything above 90 would be a distinction. What I didn't want to do was to lay out, okay, 0% is a fail, 1% is a fail, 2% is a fail. That would make a very long lookup table. By using the nearest match thing that we're going to use now, we can have a table like this that has thresholds. Once you reach the next threshold, you reach the next value to look up. So how will this work with our dancers? Well, here we're going to look up Jill's exam 1 score. So equals VLookup. We're looking up her score, and we're looking it up in the grades table. Now I actually haven't named this table, which I ought to have done, but we'll do it without naming to show how much messier the formula looks. Let's make that absolute while we're here, comma, column 2. There is one advantage to highlighting the table as opposed to using a named lookup, in that you're there so you can see which column you need, comma. This time I need to be true. I need to be the approximate match. Now it says approximate match, but it works on a sorting principle. As long as your lookup table is sorted in order, A to Z, so ascending order, then this will work. If your table's not sorted at all, or sorted descending, then it doesn't work the same and it doesn't go to the next threshold. So we have true at the end of our formula and return. We've seen that Jill's got 45%, so when I press return, that should be a fail, and it returns a fail. Let's just test her out by pushing her up to 75%, and that turns into a pass. Checking my little table, 75% is a pass, but if she happens to get 92, she really did well. She gets a distinction. So that's breaking the 90 threshold, takes them to the distinction level. However, she didn't. Let's go back down to 45 where she was, which was a fail. So I can then take this formula and replicate downwards, just checking that everything is relative that should be. Relative is the lookup, fixed is the table. Notice how much longer it is when you're having to reference the sheet as well as the cells. But we can replicate that, and we get everyone else's 95 distinction, 86 merit, 56 a pass. So right on the level, 55 would still produce a pass. If I changed her score to 55, she would still pass. 54 would be a fail. So I could take this formula and paste it here. Would that still work the same? Due to Excel's relativeness, it does. I'm still looking at D2 and the table reference is fixed. So that's fine. Let's replicate. And then let's copy and paste the whole set of formulas against exam 3. We can see 34 is a fail, 76 is a pass, 95 is the distinction. So it matters the makeup here of the lookup table. It must be in an ascending order. The column that you're looking up in must be in an ascending order for it to work and make logical sense. Now we can do the same thing with sales, looking up a bonus table. So these are the sales. So the last thing I would want to do is create a massively long lookup table that has every possible sale value. So $1, $2, $3, $4, all the way up to whatever the maximum sale might be. Instead, I create a lookup table that has a set of thresholds. 0 to 5,000 to 10,000 to 15,000 to 25,000 to 40,000 to 50,000 to 75 to 100,000, each with their own associated bonus. Let's give this table a name this time. I'm going to call it bonus. And then in the sales sheet, I can then say equals VLookup. I'm going to look up their annual sales value, I'm going to look it up in the bonus table. So I start typing and it appears in the list. And I want to bring back column 2, but I need to do a approximate match. Return, and it says that our Wendy Parker here, because of her 24,750, will earn a $1,000 bonus. 24,750, so not quite 25, leaves her at the $1,000 bonus. Let's replicate that formula downwards, so it looks everybody up and tells us how much bonus each person is then due. So one here at 3,000, 47,000, let's double check that. To get 3,000, they must have broken 40,000, but not gained the next threshold, which is 50. So our 47 falls into that bracket, as does 45, but 38 is below 40,000, so they're on the lower bonus amount. So again, just like the grades, only works if the table is sorted, the lookup table is sorted in ascending order of the lookup values. Then you can use this nearest match instead of having to create a lookup table that gives you every possible lookup value. Works well here where we've got a massive range of possible values with the sales numbers, and certainly with the dancers' scores where the range really was only 100, but that's still 100 rows instead of our nice little 4 rows that we had. So that's VLookup with an approximate match instead of the exact match as we've seen previously.